Hello guys, today we are going to discuss a very important topic, very important component used in Arduino projects, and that is potentiometer. You might have seen potentiometer and it comes in different size and different shapes, let's say of 10 kilo ohm size, 100 kilo ohms or 250 kilo ohms. And the application, if we talk about application, it can be used to control brightness of LED or motor speed. So we'll discuss about potentiometer interfacing and all in this video, but before that let's analyze this circuit, this simple circuit which we are seeing on screen. So here we have a 9-volt battery connected to this LED with a resistance which is of initially 500 ohm. So if I replace this resistance with different values, you will see that the brightness of this LED will change. If I again change it to 800 ohm, again the brightness will change. If I again change it to 1000 ohm, again the brightness will change. So this, like this, what if you, let's say you want to change the brightness of LED, again and again you need to replace the resistance with different values. But this is not the right way to control the brightness. What is the next option? The next option is potentiometer. So friends, this is potentiometer. This is simulation. First we'll see it in simulation, then we'll interface it with our Arduino on board, real potentiometer with real Arduino. So this is potentiometer and the size is of 10 kilo ohm. And we have three terminals, terminal 1 and terminal 2, which are connected to the source 9-volt battery, and terminal 3, which is connected to a wiper, is connected to anode of our LED. So this terminal 3 will be acting like an output. Now if let's say if I run the simulation, you will see that when I change the position of this wiper, the brightness of the LED is changing. So now I think you have understood the application of potentiometer. So the potentiometer is used to apply variable potential wherever required. If let's say if you want to see the input circuit of potentiometer, you can see here on screen. So what we are seeing, we have this resistance here which is connected to a wiper, which is terminal 3, and terminal 1 and terminal 2 is connected to our source, let's say 5 volt. So from this output terminal 3 we get variable potential, and wherever we be the slider on this resistance, 10 kilo ohm resistance, will get equivalent output at that point. If we talk about the minimum current flowing through this resistance, that will be 0.5 milliampere. You can calculate it using Ohm's law. Now let's assume that now let's calculate the value if my wiper, if my slider is in the mid. Let's say the value of R1 is also 5 kilo ohm and R2 is also 5 kilo ohm. So using potential divider rule, V output will be 2.5 volt. So you can, like this, you can calculate the value that at what position your wiper is at present, and what will be the value. Using the Ohm's law, you can calculate that too. In this case, our wiper is at the position where R1 is 1 kilo ohm and R2 is 9 kilo ohm. So in this situation, the output voltage will be 4.5 kilo ohm. So when we connect a potentiometer, this is a potentiometer we are using manually, but when we connect a potentiometer with our Arduino, where to connect? So we need analog inputs, and analog inputs in our Arduino Uno are A0 to A5. So any of these analog inputs will be used to connect our terminal 3 of potentiometer to get the variable potential. But what will be the range? The range will be 0 to 5 volt. Although you can change this range, but in normal scenario, normally the range of Arduino will be in 0 to 5 volt. So the signal sensed by this potentiometer is analog signal, but analog signal is totally different from digital signal, because in digital signal there are only two states, either it will be 0 or 1, logic 0 or logic 1, or you can say 0 volt or 5 volt, whereas your analog signal vary with time. So as you are seeing on screen, the signal is continuously changing, the amplitude is continuously changing with time, and for sensing this analog signal, there is internal ADC, analog to digital converter, in our Arduino board, and the resolution for that ADC is 10 bit. That means we'll get 2 to the power 10, that means we'll get 1024 different combination to sense the signal at the input, with a step size of 4.88 millivolt. So the minimum value which Arduino can sense will be 4.88 millivolt. The internal ADC will take the signal, sample it, quantize it, and then convert it into equivalent code. I have shown you this diagram here in which I am taking 3-bit resolution. So 2 to the power 3 means there will be total 8 combination, and this is a signal sampled at 0.1 on every 0.1 second. And you can see that on sampling we are getting code. The first sample is at 100, we have got a value of 100, and let's say the full scale is 5 volt. And then second signal is sampled at again 100, third sample is sampled at 101, fourth is at 111. So like this the signal will be sampled, then it will be quantized, and then it will provide equivalent digital code.
So friends, first we'll interface our potentiometer with our Arduino board. Here we have 3 terminals. So terminal 1 will be connected to ground, and terminal 2 will be connected to our VCC, which is 5 volt in our case, and this middle terminal which is connected to the wiper will be connected to our analog input A0. So interfacing is very simple, so you can interface it like this. Now we'll move to the programming part. So we are going to analyze the data, whatever analog input we are sensing through A0 will be analyzed on serial port, and for that we need to initialize the baud rate first. So we'll initialize it with 9600 bits per second, and we'll print it on our printer. So simply you need to drag and drop this analog read analog pin A0 to your serial print block, and we'll give a 1 second time delay. So now let's upload the program on Arduino. Program is uploaded. We'll see there on serial monitor. So here you can see that when I turn or when I rotate this potentiometer, I'm getting variation in the value, input value. This potentiometer is not that precise. That's why we are getting a little problem. But still you can see that if I change it to 0, initial position we are getting 0 value. If I turn it to the maximum position, we are getting 1023. And why we are getting 1023? Because it input resolution is of 10 bit, which is 1024. So like this we can analyze the input analog data connecting our potentiometer with our Arduino board. Okay guys, so in this program we'll be seeing that how we can display the equivalent voltage value for our analog read value through pin A0. So what we have done, we are using one variable here with the name step size, and we are storing this value. And what is this value? This is the step size. You can see the formula here, and we need to be divided 5, which is our reference value 5 divided by 1023, but there is not, it's not accepting the float value. Therefore we are writing 4 decimal 999. So hardly it will impact our value. So just for the sake of showing the proper result, we are using 4.999. Now in the loop, what we are doing, first we are displaying a string with the name analog value, and next we are whatever be the value at A0 will be displayed there on serial monitor. Then in order to get the voltage, equivalent voltage, we are multiplying the analog value with the step size. So step size already calculated here will be multiplied with the current value read at analog pin A0. And finally we are printing a volts in front of that equivalent voltage value. And with this 1 second delay, we are going to display the value on serial monitor. So now let's upload the program. Okay, so now you can see here that whatever be the value at A0 will be displayed in its equivalent voltage form. So you can see here that whenever I am rotating this potentiometer, the variation is there, and that variation's equivalent voltage is also displayed there on the serial monitor. And if I rotate it to its final position, I should get 5 volt, isn't it? So I'm getting 5 volt for 1023. So like this you can also display the equivalent voltage for your analog value. Then in the next program we are going to see that how can we use a map function in Arduino. In this program we'll see that how can we use this map function which you can find in maths category. So this map block is used to map values between two ranges. So what we are going to do, we are changing the range which is in the range of 0 to 1023 for our analog input in the range of 0 to 200. So what I have done here, I'm going to use the map function, put value, whatever value I'm reading this block here, and from 0 to 1023 value will be displayed in the range of 0 to 200. To check it, let's upload it, and then we'll check it there again on serial monitor. Here you can find that whatever be the analog value, its equivalent mapped value will be displayed there. So look, for maximum 1023, what is the mapped value? 200. And in the similar way, for whatever be the value, its equivalent mapped value will be displayed there.
One more thing is here, Arduino's analog inputs resolution is in the range of 0 to 1023, whereas analog's output resolution is in the range of 0 to 255. So to match this resolution, what we use this map block. So we'll range 0 to 1023 using this 0 to 255 range using this map block. Although you can use you can divide the input value by 4 and then you can write it on analog output. That is also one option, but this is the simplest way by which you can fix this problem in Arduino.
So now if you will upload it, you will see that this value 0 to 1023 will be mapped in the range of 0 to 255. So like this you can use this map block not only in defining the range of output pin, analog output pin, in other ways also, in other applications also. So this is one of the block in maths category which you can use for your program. So you can check here on the monitor. Here also you can see that the mapped value now is in the range of 0 to 255. Okay guys, so this is all about potentiometer interfacing, and in this video we have learned about how we can interface a potentiometer, how we can read analog input, and how to map these values, and we have analyzed all the values there on the serial monitor also. In the next video we are going to interface one LED, and we will be controlling the brightness of that LED using this potentiometer. And guys, please check this Arduino equivalent code also whenever you are writing your block code for your project. Okay guys, if you have any query, any question, please write in comment section. We'll be happy to help you, and we'll see you in next video with LED brightness control. Till then, take care. Goodbye.